The James Webb Space Telescope just revealed something that could completely change how we look at alien life. And the truth is far stranger than anyone expected. For years, scientists believed the TRAPPIST-1 system was one of the best chances to find another Earth. 7 Earth-sized planets, all packed around a nearby star just 40 light-years away. Some of them sit directly inside the habitable zone, the perfect distance where liquid water could exist. But there was always one giant question. Do these planets actually have atmospheres? Because without an atmosphere, a planet is basically dead. No breathable air, no weather, no protection from radiation, and almost no chance for life as we know it. Now, after years of waiting, the James Webb Space Telescope has finally delivered its first major results on TRAPPIST-1, and the findings are both exciting and brutal. Some planets turned out to be scorched wastelands. Others may still hold hope. And one planet in particular is now at the center of one of the biggest scientific mysteries in space exploration. Today, we're going planet by planet through the TRAPPIST-1 system to uncover exactly what James Webb found and why scientists are more divided than ever about whether alien life could exist there. Before we get into the discoveries, we need to understand why TRAPPIST-1 became so famous in the first place. Back in 2017, astronomers announced something unprecedented. Around a tiny red dwarf star called TRAPPIST-1, they discovered not 1, not 2, but 7 Earth-sized planets. That alone was shocking. Finding a single rocky planet similar to Earth is already difficult, but finding 7 in one compact system completely stunned astronomers, and the location made it even more exciting. The system sits only about 40 light-years away from Earth in the constellation Aquarius. In cosmic terms, that's practically our neighborhood. The star itself is also incredibly unusual. TRAPPIST-1 is what scientists call an ultra-cool red dwarf star. It's only slightly larger than Jupiter, but much more massive. Unlike our Sun, this star is extremely dim and cool. That changes everything. Because the star produces so little heat, its habitable zone exists incredibly close to the star itself. In fact, the entire TRAPPIST-1 system could fit inside the orbit of Mercury in our own solar system. That creates both huge advantages and terrifying problems. The advantage is that these planets orbit very quickly. Some complete an orbit in just a couple of days. From Earth, this means the planets constantly pass in front of their star, giving scientists repeated opportunities to study them. And that's exactly where the James Webb Space Telescope comes in. Webb was practically built for this mission. When a planet passes in front of its star, some starlight travels through the planet's atmosphere before reaching us. Different gases absorb different wavelengths of light. Water vapor absorbs certain wavelengths. Carbon dioxide absorbs others. Methane leaves its own unique signature. By analyzing the missing wavelengths, scientists can determine whether a planet has an atmosphere and even identify what gases exist inside it. This technique is called transmission spectroscopy, and James Webb is the most powerful instrument ever created for this kind of observation. But then comes the downside. Red dwarf stars like TRAPPIST-1 are often violent flare stars. They unleash massive bursts of radiation, far stronger than typical solar flares from our Sun. And because the planets orbit so close to the star, they take the full force of that radiation. Over millions or billions of years, those flares can literally strip atmospheres away from planets. There's another issue too. Many scientists believe these planets are tidally locked. That means one side always faces the star, while the other side remains in permanent darkness. Imagine one half of the planet baking endlessly under constant daylight, while the opposite side freezes in eternal night. Could life survive in conditions like that? For years, nobody knew. Until now. Let's start with the innermost planets, TRAPPIST-1b and TRAPPIST-1c. These worlds orbit extremely close to their star, completing full orbits in just 1.5 and 2.4 Earth days. That makes them scorching hot and far from habitable. Still, scientists studied them to check if any atmosphere exists. James Webb found both planets likely have little to no atmosphere. The extreme temperature differences between their day side and night side suggest they are bare, rocky worlds with no protective layer. While this rules out life, it confirmed something important. JWST can clearly detect whether a planet has an atmosphere or not, proving the system is working perfectly. Then came the first major shock, TRAPPIST-1e. This planet sits near the inner edge of the habitable zone, where temperatures could potentially allow liquid water to exist. For many scientists, it quickly became one of the most promising targets. James Webb observed multiple transits of TRAPPIST-1e, searching for signs of water vapor, methane, and carbon dioxide, while the scientific community waited for a breakthrough. But the results were disappointing. The data came back completely flat. In astronomy, that usually means starlight passed through almost no atmosphere at all. There were no clear signs of water, methane, or carbon dioxide. Scientists were forced to conclude it is likely not an Earth-like world, though a thin, Mars-like atmosphere or hidden cloud effects still can't be fully ruled out. Attention now shifts to TRAPPIST-1e, the true crown jewel of the system. So what did Webb discover? The answer is complex. Scientists ruled out a thick hydrogen atmosphere, meaning TRAPPIST-1e is not a mini Neptune and is likely a rocky, Earth-like planet. However, there's also little evidence for a thick carbon dioxide atmosphere like Venus or Mars, which makes the picture less clear. The biggest challenge is the star itself. TRAPPIST-1's star spots and strong activity can distort data and mimic atmospheric signals. After correcting for this interference, scientists are left with two possibilities: a barren rock with almost no atmosphere, or a more exciting scenario, a nitrogen-dominated secondary atmosphere, possibly with traces of methane, which could hint at conditions suitable for life. Scientists are being very careful here. No one is claiming alien life has been found, not even close. But for the first time, JWST data suggests that TRAPPIST-1e could still support an Earth-like atmosphere. Because the planet is likely tidally locked, the most promising region for habitability may be the terminator zone, a thin band between permanent daylight and endless night, where temperatures could stay stable enough for liquid water. Still, the story is far from over. James Webb has multiple new observations planned to remove stellar interference and finally determine whether TRAPPIST-1e truly has the kind of atmosphere needed for life. Farther out in the TRAPPIST-1 system are TRAPPIST-1f and TRAPPIST-1e, colder worlds that receive less stellar radiation, which may actually help them retain atmospheres over long periods. Early observations suggest they also lack thick hydrogen atmospheres, meaning they are likely rocky planets. But beyond that, data remains limited, and scientists still don't know if they have nitrogen atmospheres, carbon dioxide layers, subsurface oceans beneath ice, or nothing at all. They remain major unknowns in the search for life, showing how the James Webb Space Telescope is gradually narrowing possibilities rather than giving instant answers. A few years ago, scientists hoped TRAPPIST-1 was a system filled with multiple Earth-like worlds, but James Webb revealed a far more complicated reality. Some planets appear dead and airless, while others may still hold thin atmospheres. The biggest mystery remains TRAPPIST-1e, a world that could either be barren or potentially capable of supporting life in its permanent twilight zone. We still don't have the final answer, but for the first time in history, humanity has a telescope powerful enough to investigate these distant worlds in detail. And with every new observation, we move closer to answering one of humanity's biggest questions: are we alone?